in your frustration.
And then,
You are not alone. I was trying to do that one the other day and I couldn't figure it out.
Is this one it? What is this? Okay, there's a balloon, but how did I get the balloon? I just clicked something and I don't even remember what it said.
So the balloon is there. That's part of the setup for the lab. And
oh my god.
now that
Hi, Dusty. I'm sorry. I didn't mean to freak out in front of you, Doc. Hi.
I'm Dinty. I prefer Dr. Musk, but Dinty works as well in a pinch.
Sorry, I
No, it's
confused.
totally fine. As a matter of fact, there is Dusty who teaches math at SVC as well. And
yeah,
we
I
get
just
called each
had
other's
them
names.
for-
Yeah. We get
Yeah.
called each other's names all the time. You're not the first, nor shall you be the last.
I'm sorry, Mr. Musk / Dinty. Hello.
I'm pretty sure it's doctor.
It is doctor.
Dr.
I have my
Musk,
PhD in chemical biology.
So Dr. Musk, I have to say, I enjoy your cat's meows through every single one of your like YouTube, for the reading quizzes, because I hear them
thought
in
I
the
was
background.
That makes me
that.
sad. That was Oscar. He passed away about a month and a half ago.
Oh no!
Bummer, huh?
I'm so sorry.
It's okay. I have a new cat that meows in a really gruff way. It's not like Oscar, but it reminds me kind of the same way. So
I have a cat who doesn't know how to meow. When he tries, it sounds like he's being strangled.
yeah, we
He
have
does
one of
this
those
chirp.
too. It gets caught in his throat.
Yeah, he chirps all the time. He's like, because he does not know how to meow. It's funny.
Yeah, my grandma's cats, only 2 of them will like actually meow. And that's when you go to pick them up when they don't want to be picked up. It's kind of sad.
Yeah, we lost Oscar. He had cancer, so he was 13 anyway. He was getting to be sort of a senior. So we adopted Mr. Mortimer as our new cat. He's a Russian blue. He's really pretty and super friendly. Also skittish, but he had actually taken up with a colony of stray cats outside the Skagit County Humane Society, but he didn't run away when they came out to like check on everybody else. So they figured he had been owned before, and he was neutered, so he was either dumped or an escapee or something like that. But he's awesome. They didn't know this, but he had tapeworms. I figured that out. We treated him for tapeworms a couple of days ago. They're easy to fix. That's not a big problem.
Oh,
but
yeah.
He did have them. And my other cat got them too, of course. So, okay. So this week is our week to do extra practice with chapter 2 kinds of things. I'm going to sneeze in a minute. So also, if you're having any last questions, I told you I was going to sneeze.
Bless you.
Bless you.
Thank you. If you have any last questions about the chapter 1 Alex homework, which is the due date for that is coming up in a couple of days, we can certainly look at a topic or two from the chapter 1 Alex, or we can look at the main important parts of chapter 2 together.
I have a question.
Go ahead.
About part of chapter 1. It's here, hold on. No, wait, I gotta make it the zoomed in one so you guys can see it.
Is that the what's the missing unit?
Yeah.
Okay, so why don't you share your screen so it's the whole screen so everybody can see it?
Oh, yeah, okay. Screen, Alex, share. This one.
Sweet. Okay, so what we're doing is we are looking to cancel out units and see what units are left over. All right, so we're supposed to put in the missing unit that makes everything else cancel out the way it's supposed to. So right now, yep, grams in the numerator and denominator cancel. So milliliters are not going to cancel because those are the units that we want left over, right? Those liters are in the denominator, and those moles, believe it or not, are in the numerator overall. So do you guys understand why that is? So the moles would be in the numerator because that's the same as being in the denominator of the denominator. Let me go ahead and share my screen for a second. So for example, where is it? Oh, my document camera is off. That's why it's not working. Much better.
And I wish I could doodle on the screen like that all the time. It's very helpful.
Yeah. I mean, I do have a touchscreen laptop, but I prefer pen and paper, to be honest. I really have gotten to like this document camera. So I'm going to keep on doing something similar to this when I go back.
Yeah, I get that.
So if we simplify this expression, 1/1 is 1. And then 1/x, if it's in the denominator, if we're dividing by 1 and then divide by x,
We
then
can't
that's,
see your,
Doc,
oh no,
can't see your screen.
I'm just looking at your face.
I don't understand. Let's try again.
I do have a meme for this, actually.
Oh, you thought you were screen sharing, but you're not? That happens to me all the time. Sorry.
It's the 4-page setup of GRU.
So dividing by something that is in the denominator of the denominator is the same as multiplying by that thing. All right. So if we want our units to cancel out, I'm going to stop my screen share. Juliana, will you share your screen again so we can look at the problem again together? Did you left it? Okay.
I have a new one if you want to
No,
look at
it. I'll do it on my screen so that we can have both things together. So it'll take me just a second. I'm going to go to Alex and open up that topic.
I have the same exact one that she had open in my notes because I did a whole section on it because I didn't understand it. So
well,
I went
the
into the
exact problem
explanation.
isn't as important as the how. Like, what's our strategy for solving that problem? We just have to figure out what units will make the rest of the units cancel out the way they're supposed to. And it's an important skill because getting units to cancel with conversion factors is kind of how we solve like 75% of the problems that we do in this class.
I like being able to cross things out like I was doing in the screen sharing. I was like, oh, this makes things a lot of sense. But now I'm just like,
Okay, so during office hours today, I took 1 minute and completed all my homework for the quarter because I get to skip everything and just say that I know how to do all the problems. So now I'm in review mode. Now, if you guys go to review mode here, you can do the same thing after you turn in an assignment. You can go and pull this drop-down menu and go back to any chapter's topics that you want to and look at any of those topics again and get more and more examples. It's a good tool to use when you're preparing for exams. All right. So I'm going to go into chapter 1 homework and
deducing something with basic.
Deducing the unit missing.
The unit missing
Yeah.
from the solution.
All right. So we got a pretty similar one to what's going on here. So what I'm going to do is I am going to lose my cursor completely for a second. Okay, now the first thing that we don't have to worry about here is we don't have to worry about numbers at all. All right. What we have to worry about is what are the units going to look like that will allow us to end up with the units shown in the problem. So right now I have liters times milliliters over liters times grams over milliliters. And then in the denominator, we have some unit left over. And when all that is canceled out, we should end up with moles as our unit. So what we have to do is we have to solve for what units are left over here to put into the equation. We can do this actually with algebra by isolating and solving for x here. That's one strategy. So if I rearrange this equation by multiplying both sides by x and dividing both sides by moles, I'll end up with this equation instead.
Sorry.
So it looks like those are our units for x. Now let's cancel out the units that can cancel. So liters divided by liters, those cancel. Milliliters divided by milliliters, those cancel. So what units are left over? Grams divided by moles. So those should be the units that are left over for x right here. So grams over moles should be what we put in. And let's check. So that is all we're doing, is trying to figure out how to make the rest of the units in the problem cancel out. Let's do one more of those together. Sweet. So I'll give you guys a second to think about this one. Remember the strategy that we used, that unknown there is a variable, right? We can just solve for what's left over using algebra. The numbers don't matter. All that we care about is the units. So here's what I have. I've taken out the numbers and just left in the units. Now let's simplify as much as we can. Liters in the numerator and denominator cancel. Kilograms in the numerator cancel with kilograms on the other side of the equation. So we can divide both sides of the equation by kilograms. So then we end up with milliliters times x divided by grams should equal 1, because dividing both sides of the equation by kilograms leaves us with just 1 on the right-hand side. So if I multiply both sides of this equation by grams, I get, oh, that's milliliters. I get milliliters times x is equal to grams. And if I divide both sides of the equation by milliliters, then the leftover unit is x is equal to grams over milliliters. So we can check. Let's put that unit in. And then make sure that all the units cancel out to leave us with just kilograms. So it looks like liters cancel out with liters, milliliters cancel out with milliliters, and grams cancel out with grams, and we're left with just units of kilograms. So that's how I would approach problems where we're just trying to figure out what units are missing. Is that helpful? The couple of you who had questions about that topic?
I have a question on how to use Beyond Labs. It's giving me some issues on
Okay.
how I
So
use it.
What's your question?
So I was doing the I was doing a reaction the pH lab, and I couldn't get the sodium out of the container.
The pH lab? Isn't that like way, way far ahead?
I don't know. I was clicking on random labs just to see if I could get them to work.
Okay. So you're just messing around with it?
Pretty much.
Okay. That's totally fine. Normally to get something out of a container, you have to weigh it. So you have to take it over to the weigh station.
That's what I was trying to do.
So I might actually have to reactivate my subscription to Beyond Labs. I haven't been on this quarter yet. Give me just a second, because it's been about a year since I used my code. I may have to use one of our codes to get access again.
So which one are we supposed to do? Chemistry, organic chemistry, biology? Like which are we supposed to download?
I'll show you in just a second.
I'm asking the teacher.
Yeah, I'll show you in just a second.
Thank you.
Okay, so it looks like my code is still good for now. That's excellent. I'm going to share my screen. So the labs that we will be doing for this class come either out of the chemistry suite or out of the physical science suite. Okay.
Okay.
And some of them will come out of, the ones out of physical science will come out of high school physical science. That doesn't mean they're just high school experiments. They're basic experiments that teach us important things about how science works. So high school, college, whatever, we're learning about like the basic tenets of how science works. And I think most of our chemistry labs over here will come from the higher ed side. The first lab, I think, comes from high school physical science. So if I open that list of experiments, the very first one under structure and properties of matter is the introduction to scientific inquiry, and that's the first lab.
Okay, thank you so much.
You're welcome. And I think that that was in the tutorial video, but maybe I skipped over it, or maybe it's changed places or something. So I know that the interface looks a little bit different now than it did then.
I didn't even see the tutorial video, so that might have been my fault.
It's in the video.
I didn't see it either.
The tutorial videos, they are on the course Canvas page, but you're going to have to scroll down just a little bit to get to them. So if you look, here's the course Canvas page. If I just scroll down to lab activities, there's lab 1. So that's the printout, or what, you know, that's what you're going to fill in and submit for lab 1. Right under that is the lab 1 tutorial. So there's a video there that walks you through how to get to it and how to complete the experiment.
And are you big on like wording exactly how you want things done? I know some professors are very specific about that, or do you just want us to get the answer right? Like,
I want you to get the answer right.
Okay.
So I have a question about the lab too, because in that tutorial, that specific video, you said that we could either like do it in the Word document and type it in, but you kind of preferred, especially when we're drawing, like to draw it out. So for that one, like we don't necessarily have to draw anything, so we're good typing it, right? Like,
so there is one thing that you have to either draw or graph. So you're going to have to graph your results of the experiment. You can either draw that graph, or my preference would be to make a graph using Microsoft Excel or some other spreadsheet program. So yeah, you can type everything in. If you want to just use Excel to make your graph and then import it, that's totally fine.
I don't have access to Microsoft Word, Excel, or PowerPoint.
So
Google Documents.
Google Documents has all those same things, and it's available on the web. So you can use Google Docs to do the same thing with.
It gives me trouble when I try to upload stuff from Google Docs. I was wondering what I should do.
I would try exporting it as a photo. So you can export your graph as a JPEG. That's probably what would work the best.
Or if you go into your search bar, I don't know if you have Windows, I assume.
I have an HP computer.
Do you have a little like type here to search at the bottom left-hand side of your screen?
Yeah.
Type in snip, S-N-I-P. It's the snipping
Oh
tool.
yeah, I put that thing on my
So you can snip
tool bit.
the graph and you can move it onto your document.
You also have access to Office 365 being a student.
Yeah,
So if you
you
go to
can
like,
download the entire Office suite of programs for free. So even if you didn't think you had Office, you have it. You can download it right now.
I don't know how to get it.
Okay.
Would you like me to show you?
Yes, please.
Okay, cool. Okay, hi. I forgot I was muted and I didn't know when it was an appropriate time to talk. Okay, we're gonna start from the beginning. And by the beginning, I mean my bookmark for my SBC.
How about you share your screen for a second?
Oh, the normal way? Okay,
Yep.
yeah, I can do that.
So that everybody can see instead of looking at just your little panel, because I can't
Okay.
see anything there. My old eyes won't let me.
Okay, so we go to the mysvc.skagit.edu web app page thing. Okay, and then you go under Help Center. You scroll down to here. It says download Microsoft Office. You click this. And then it shows you step by step how do you do this. First, you're going to keep this tab open while you open up this one. And then you set this up with the instructions, which says enter your SVC username, which is like your email, but instead of the at mysvc.skagit.edu, you swap it for at skagit.onmicrosoft.com. That's the main trouble. Other than that, you enter
Olivia,
the same.
do you think once you get to that page, you can follow those instructions?
Yeah.
I think you can too. I am totally confident in your ability to do that. So now you know where to go to get the instructions, and you have the entire Microsoft suite or the Google suite, the Google Docs suite of programs works just as well. It's just in terms of the spreadsheets, the buttons are in slightly different places. So I use Microsoft Excel for everything. I have for like 20 years at this point, but I could probably help you with Google Docs if you popped onto office hours and wanted to use that instead. It would just take me a minute to find how to do what I wanted to do.
Okay.
Dr. Musk, can you show your Canvas page again, please?
Yeah, I saw that. How did you do that?
Oh, I can click annotate in Zoom too, and we can draw on each other's pictures.
That was okay. That was pretty sly. I didn't. Go ahead.
Yeah, so the other thing you can do is this Google Drive here. You can link your school Google Drive straight to Canvas, and then you can just import your assignments back and forth using Google Drive, so you don't have to convert them.
Okay.
So if you need help, let me know.
Okay, thank you.
Mm-hmm.
Yeah,
I'm
I was
not great
wondering
with
where those
computers.
circles came from. Like, did I do that by accident? That looks a little too clean to be mistakes. That's awesome. Okay, so are we good with how to access the first lab and where that's at? All right, course Canvas page, just scroll down. There's a tutorial right underneath it that will help you go through the steps. We're good with the rest of the topics for Alex Chapter 1, which is due, I think, Thursday, if I remember correctly.
Friday.
Thursday at midnight? Friday at midnight? Okay. I'm very bad at remembering dates, so just to let you guys know. That's why what I'm going to try to do is at the beginning of every week, send out an announcement with the due dates that are in that week so that students keep those in their brains, especially since the due dates, we haven't added them into my course Canvas page yet so that you get an alert that an Alex assignment is due. Right now, the only way to keep track of those is in Alex. I'm going to try and fix that over the next couple of days.
Yeah, if you're in the support class, I do have the due dates. So you're getting announcements for that if you're in the support class.
And we're gonna fix my Canvas page so you get announcements there too. I just haven't figured out quite how to do it yet, or the right way that I want to do it in terms of like attaching those to the calendar. Okay, so chapter 1, any last requests for extra help with chapter 1 topics before we move on to chapter 2 topics? So chapter 2 is what we should be spending most of our time on this week. Structure of the atom, a tour of the periodic table, and electron configuration and other things that the periodic table can help us figure out. So I'm going to start adding reading quiz deadlines toward the end of this week for chapter 2 reading quizzes as well. So I probably should have added chapter 1 reading quiz deadlines earlier, but I just didn't want to start throwing bunches of deadlines until we had everything squared away with how to get people working on labs. So have you guys started watching chapter 2 videos at all yet? Or are we still finishing?
I'm done.
You're done with chapter 2 videos?
Yep, and I'm done with chapter 3, Alex. But I'm weird. I have
You're
too
done
much
with
time.
chapter 3, Alex, already?
Yeah, I have too much time on my hands.
I wouldn't. Okay, you may just become like the person that everybody turns to when they need extra help on Alex. Now that you
No,
let that
I'm used
go.
to working 12-hour shifts, and I quit my job to go to college. So now I'm like, I don't know what to do with my hands.
Well, I know what I'm doing with my hands. My office is way too warm right now because it's nice out today, so I need to open the window. Okay, so big topics from chapter 2. We have to make sure we understand the parts of the atom. We have to understand some notation about how we talk about those parts of the atom. So let's do a couple of examples. What is going on? Sorry, I was having a little bit of bugging. So let's look at a periodic table for a sec. And what I want to focus on is just one element symbol. And it doesn't really matter which one, but let's look at cobalt for a second. All right. So cobalt, if I talked about a specific single atom of cobalt, to describe that atom, you will often see two numbers to the left-hand side of cobalt. The number that exists down here is one that often is omitted completely. And the one that exists up here is not omitted because it's super important and we can't know everything about this cobalt without that number. I'm going to sneeze again in a second too. So let's say that this particular cobalt was a cobalt 61. Now, if we look at the symbol for cobalt on the periodic table, which it's right there, you'll see that the first one of those numbers is the same as this number right up at the top. We call this the atomic number of cobalt. So that atomic number tells us the number of protons in that particular kind of atom. And that is what defines what kind of atom the atom is how many protons it has. So atoms can gain or lose electrons and become charged. We'll talk about that in a minute. Atoms can also have different numbers of neutrons, the third kind of subatomic particle. But how many protons an atom has tells us what the atom is. So why is it that this communicates exactly the same thing that this does? Because every cobalt atom ever has exactly 27 protons in it. If its atomic number wasn't 27, it wouldn't be cobalt. It would be a different symbol instead. So because this is cobalt, we know that its atomic number is 27. Now this top number is really important. We can't leave that out. This is what we call the mass number. That mass number tells us the number of protons plus neutrons in an atom. So from the topical videos, you'll realize that protons and neutrons are where almost all of the mass in the atom comes from. They're about 1,000 times heavier than an electron is. And if we don't see anything listed up here above and to the right of that atom, what we can assume is that atom's net charge is 0, which means its number of positively charged particles, protons, has to be the same as its number of negatively charged particles, the electrons. All right, that's only for atoms that don't have a net charge listed up here and to the right. So right now, this cobalt doesn't have anything listed up here. We'll get to some that have charges a little bit later. So if we see this 61 cobalt and are trying to figure out how many of each kind of those subatomic particles we have, the atomic number of cobalt from the periodic table tells us that cobalt has 27 protons. And because cobalt doesn't have a net charge, we know it has to have exactly the same number of electrons as it does protons. Now, the last number, the number of neutrons, is a little bit harder to calculate. The only way that we can figure that out is by knowing that this is the mass number, which is the number of protons plus neutrons in the atom. So 61 minus 27 should be the number of neutrons for this atom. And unless I screwed things up, I think that's 34 neutrons. So what if instead we had some kind of a charge listed to the top and right? All right, and this is all in the topical videos, but we're just doing more examples just to practice more here. All right, one of the main things that we learn in this part of the chapter is that the number of neutrons in an atom is the thing that can change even for neutral atoms. So the example, one of the examples that I get.
Doc,
Go ahead.
I have a question.
Go ahead.
27 plus 27 plus 34 equals 88.
That's right. So does it say that the mass number equals the number of protons plus neutrons plus electrons?
Oh, okay, thank you.
You're welcome. The reason why we don't count electrons in the mass number is because electrons almost weigh nothing. All right. We actually have this scale called the atomic mass unit scale. So AMUs is a mass unit, atomic mass units. Now, atomic mass units are another mass scale just like grams. They're just a scale that's adapted to weigh things that are really, really tiny, like protons and neutrons and electrons. So on the atomic mass unit scale, one atomic mass unit is about how much a proton weighs. One atomic mass unit is about how much a neutron weighs. About 1/1000th of an atomic mass unit is about what an electron weighs. So on that scale, if we're talking about this number, the mass number, we're talking about approximately how many atomic mass units there are total in that substance. And because of that, we count up the number of protons and neutrons. We ignore the electrons because they weigh almost nothing on that same scale. Juliana, does that help? Good. So right from the topical videos, we talk about examples where the number of protons and electrons are the same for an atom, but that atom can have differing numbers of neutrons. So hydrogen is an example that has 3 of these different kinds of hydrogen. These are all hydrogen. It's just they have varying numbers of neutrons. So that hydrogen, just for practice, has 0 neutrons in it. This hydrogen has 1 neutron. That hydrogen has 2 neutrons. So vocab from chapter 2, we call these different isotopes of hydrogen. All right. Everything's the same about them except they vary with their number of neutrons. The number of neutrons in an atom can change. Those are different isotopes of that element. So let's look at another one of these together. This is chlorine 37, but that signifies that it has a -1 charge. So if we have something that has a -1 charge, we just put minus next to it. If it had a -2 charge, like for example, this oxygen atom, a -2 charge would be written as 2-. I'm just the messenger. I don't know why we put the number before the sign, but it's the way we do it for atoms that are charged. Atoms can have positive charges too, like for example, cobalt could exist with a +2 charge. So what I want you guys to think about is what that means for how many protons and neutrons and electrons this chlorine would have. So take a second and see if you can figure out how many protons and neutrons and electrons that chlorine has. And I'm going to zoom a little bit so you can see right here, there is the symbol for chlorine on the periodic table. I also in the first Canvas module included a link to a very similar periodic table to this. So you could download that. If you have a printer, I would print out a few of them and just keep them around your workstation because they're really useful. That periodic table is a lot better than the one in the front of the book.
I'm sorry, where's that periodic table? Because I don't like the one in the front of the book.
I don't like it either.
Home, okay.
So I'm just going back to the front course Canvas page. And then if you look down in the important documents, right there is a PDF of the periodic table that you can download and print bunches of copies of.
Oh, thank God. Thank you.
Yeah.
Oh, thank God.
I have lots of copies because I color them differently depending on what we're studying. So if you like colors, it's nice.
And I have bunches of copies because I write all over them when I'm going through examples with students, and then they finally get too messed up to use anymore and just trash them and use new ones. So I print about 10 or 20 for each quarter to talk through different examples as we're going through. All right, so how many protons are there in this
17.
chlorine? How many?
17.
17. Okay. There are 17 protons. We know that because every chlorine ever in the history of the universe has exactly 17 protons in it. Even before the element named chlorine was picked for atoms with 17 protons, anything with 17 protons, the way that we talk about it, that's a chlorine. Okay. So what about the number of neutrons? We'll do neutrons first.
20.
Yes, our number of neutrons plus protons has to equal that mass number. And then finally,
18.
very good. So whenever we talk about a charge here, that charge has to do with that atom having either lost some electrons or gained some electrons. So that negative charge means that this chlorine has to have exactly one more negatively charged particle than it does positively charged particles. So the net charge on this thing is a -1 because we think of protons as having a +1 charge and electrons as having a -1 charge. All right. So if we were talking about a cobalt with a +2 charge, we're not worried about how many neutrons this cobalt has at this point, but every cobalt ever that's a +2 would have how many protons and how many electrons in it. So here's cobalt right here. I'm gonna re-maximize it. Boop. So how many protons and how many neutrons? Sorry, how many protons and how many electrons in that cobalt +2?
27 protons and 25 electrons.
So it's 27
thinking right.
protons, 20, you said 25 electrons?
Yeah, if I'm thinking right. I might be very wrong on that.
You're thinking correctly. And the reason
thank you.
why is we know that the net charge of this thing is a +2. So the only way that we can end up with a net charge in an atom isn't by gaining or losing protons. That doesn't happen in our class, all right? And even if we changed our number of protons, it wouldn't be cobalt anymore if it didn't have 27 protons. So what happens when atoms become charged is they either gain or lose electrons. This cobalt has lost 2 electrons to end up with a +2 charge. I think that I put a tour of the periodic table into the topic videos for chapter 2. Catherine, can you confirm for me?
Yes, it's the
There's
very
a
first
tour of the
one.
periodic table in there?
Yeah.
Okay, good. Because for some reason, I've had those topical videos for chapter 1 and 2 up for a long time, and I always had this fear that I left the tour out of the chapter 2 videos for some reason.
No.
But I guess
Yeah, no, it's in there. The main group, the little line thingy that separates. Yeah, it's
Yep.
yeah, it's all
Okay.
in there.
So make sure that you know those parts of the periodic table. So particularly the difference between nonmetals and metals. All right, that's really important to us because that changes the way that those atoms behave in chemical reactions. So believe it or not, I could get a PhD in chemistry by just understanding how elements gain and lose and share electrons. Like understanding the behavior of elements and how they gain and lose and share electrons, that's enough to get a PhD in chemistry. That's enough to summarize 99% of what is known in the world of chemistry. Understanding the behavior of how electrons are gained and lost and shared. That is almost all chemical reactions have to do with either gaining or losing or sharing electrons. So the only chemical reactions that don't have to do with gaining or losing or sharing electrons are what we call reactions in nuclear chemistry. That's like when we split apart the nucleus of an atom, or if we have a particle collider and we send 2 nuclei on a collision course, we can sometimes make them collide and fuse together. All right, we call that fusion. So we can make a bigger nucleus out of 2 smaller ones. Sometimes that happens. Those are not reactions that we ever have to concern ourselves with in this class. Nuclear chemistry, like, guess how many nuclear chemistry reactions I was forced to know about to get my PhD in chemistry and become Dr. Musk?
All of them?
How many? Olivia's got the answer right. 0. Yeah, I didn't have to learn any nuclear chemistry. Why? Because I'm not a freaking nuclear chemist. All right. Unless you're a nuclear chemist, the nuclear chemistry is almost useless. There are specific instances where you might have to know a little bit of nuclear chemistry. Even still, you don't have to know enough about how the reactions work. It's just knowing about notation for how radioactivity happens in some of these radioactive nuclei. So for people that are going into like radiation therapy, that might be something that you would want to study. It is not worth spending a unit on it in an introductory course. All right. If I didn't have to learn any of it to become Dr. Musk and have a chemistry PhD, then you guys in your very first chemistry course ever, for most of you, you don't have to learn nuclear chemistry either. So questions about the parts of the atom? Questions about isotopes? questions about the notation that we use to talk about individual atoms of a given element. That's probably as far as we need to go in recitation today. That's like at least a third of the way through chapter 2. We're probably not going to do any review of that tour of the periodic table because it's on the video. You can watch it 30 times if you want to. All right. I do want to do more practice this week talking about electron configuration. So make sure before you come to a recitation tomorrow or Thursday that you watch the topical videos about electron configuration. And also, I think at the very end of the chapter, it talks about like what we can learn from electron configuration in figuring out how many valence electrons there are in an atom. So make sure that you're watching through those chapter 2 topical videos to be prepared for tomorrow and Thursday. Anything else? We can do more practice problems if you want to. There's no law that says that we have to go exactly an hour, and we're at like almost 50 minutes, which is, you know, an hour if you're talking about a regular class session.
I just wanted to say I probably won't be here tomorrow just because I got work.
That makes me sad. The great thing is it's going to get recorded and posted, so you get to watch it later.
Good to know.
Yep, they're all recorded and posted. Just as a reminder, I'm gonna...
Wait, win. Jennifer, you can't just drop that and not say win.
So right here in the class recitations module, the second module down in Canvas, that's where all of our recitations get posted. There is somewhat of a delay. So sometimes I have them up the night of, sometimes it's 24 to 48 hours after, just depending on how YouTube is behaving in letting me do uploads. All right, so I've got to do file conversions and then upload to YouTube. Catherine, you have a question?
Is it your birthday?
It is my birthday.
Wait, like today?
Yeah.
Happy birthday!
Happy birthday!
Wait, okay, guys. Okay,
No,
you guys
please
ready?
don't sing. Please don't sing.
Aw.
It's okay though. I really appreciate that. I don't need people to sing happy birthday to me to feel appreciated and loved. So thank you guys.
Oh, okay. Well,
Happy
now I feel like my
birthday,
choir
doll.
skills are useless.
No, plus it's a copyright violation to use that song without licensing.
Happy
point.
birthday from the
If you
kitty
ever,
cat.
what a cute cat. I love that cat. I want it. I want all the cats. My
You're not
wife
allowed
says
at my
I'd be,
house. I
I'd
have
be a
2
crazy
black
cat
fluffs.
lady if not for her influence. I'd have like 30 of them for sure. I love cats.
Logan,
That's great.
here, I'm sending
That's
you
the
to
one I could
chemistry
reach. There's 3 other ones somewhere around here.
I like that. That would be my house if I could, but we have a cap limit of 2. Whenever one dies, we just replace it with another one so that we have a steady number of 2 in the house at most times.
There was 5 at one point, but the 5th one was my cat and then it died.
Yeah, that happens. That's rough too. And the one that died a couple of months ago, Oscar, he was totally my buddy. So it's a bummer. But he was a good cat and he had a good life. And we picked him up as a street urchin back when we lived in Georgia. So he has seen a lot of the country at this point. He had a good life.
Georgia's a long way from here.
It is by way of Ohio. I had a job in Georgia and then a job for a long time in Ohio and then out to the Pacific Northwest. And I hope this is the last job ever. So I do have tenure now, which is awesome. I'm not taking undue advantage of that, but a little job security is really nice. If they really want to fire me, they can still find a way to fire me.
You have quite a few inbox messages
Me? Where? What?
in
Ye-
Canvas.
Your inbox says 71, dude.
It's, yeah, that's not real. Anytime that somebody submits an assignment or if there's something like all that stuff goes into the inbox. And if there's an actual thing that needs to be answered, I normally answer it in my school email account, which doesn't always say that it's been answered in Canvas. So I clear that Canvas box out like once every couple of quarters or something, but I don't use that as my primary platform to answer students back.
I love that we're all cat people.
Yeah,
All of
I
us
love
have kitties.
Okay,
I wish
no,
I could
feel
show you
left
guys
out.
our replacement cat, Mr. Mortimer. He'll come into the room one of these days when we're doing class and I'll pick him up and show him to you. He's really pretty.
This is Sir Reginald.
I like that.
That was Machka that I showed you.
Aw.
Yeah, our naming scheme for our animals is that they all have to have old man names. So
That's kind of mine. Regal.
Edgar and Mr. Mortimer are our two right now, and Oscar was the one that passed away.
Aw.
Dear Brat.
This
This
is
is
the one
the-
that doesn't know how to meow. Something like happened, I guess, as he was a kitten, but just doesn't know.
And
I
then
love
we
all
have
your
Zoe,
cats.
but she's way over there. So
And he's fat. He's spoiled rotten. Look at this guy.
Jennifer, do you want me to hand the meeting off to you? You have a meeting session tonight for support course.
I do. I'll be switching to mine at 6:30. If anybody wants to hang out on here for now, we can do that.
Yeah, if you guys want to do more practice problems, the big one, like honestly, from everything that we've learned so far, what students mess up on, significant figures and calculations, they're going to mess up on that. And they're going to mess up on,
Conversions.
yeah, conversion factors. That's it. Those are the two big ones that students tumble on out so far. So at least we've taught the class enough times that we know where you're going to mess up and know what you need to do more practice with. Just listen and do the practice that you don't mess up.
Also, there's an S at the end of proton and neutron. Do not just stick proton, neutron. There's an S at the end of those.
Where are you talking about?
In one of the reading quizzes marked me wrong because I didn't put the S at the end. I was like,
Oh.
really?
Oh, yeah. Well, remember, it is an unfeeling machine, right? All it does is check the answer against the one that I put in there. So that happens sometimes. Sorry about that.
Oh, no big. It's an unlimited retake.
Yeah, that's the good part, right? They're just to
Yep.
make sure that you understand the concepts well enough to pass that little checkpoint for a vanishingly small part of your grade. It's not a big part of the grade at all. But if students are concerned about getting that 5% of their grade, they do the reading quizzes, and at least they're able to answer some basic questions as they're going along, right? So we want to have lots and lots of low stakes kinds of assessments. So that way, nothing is a surprise when we get to the exams and there's actually like a very big stake on those. All right, if there's nothing else, then I'm going to hand you guys off to Jennifer and have a wonderful evening, and I'll see you guys tomorrow night.
Bye.
Night.
Have a good
Good night.
birthday. Bye.
Thank you. We're just
Nice
going to eat
birthday.
pizza and watch a movie. I don't know what movie yet, but pizza and a movie is the plan for tonight. That's what
Sounds like a
happens
great
when you get
plan.
into your 40s.
That sounds like
Sounds
an
lovely.
awesome birthday
I mean,
plan.
When I was in my 20s, pizza and a movie would have been a good plan too. So yeah, it's a good plan. All right, have a good night,
Me and you,
everybody.
it's a good movie.
Good night.